Welcome to today's Energy Central Power session entitled Ameren's Distribution Grid of the Future Vision with Advanced Network Model Management. I'm happy to turn the floor over to our moderator for today's event, Chris Warren, to kick things off. Chris, welcome to the event. You have the floor.
All right, thanks, PJ. All right, I'd like to welcome everyone to our webinar today, Supporting Ameren's Distribution Grid of the Future Vision with Advanced Network Model Management. Again, my name is Chris Warren, and I'm the host for today's event. Now, I'm willing to bet that nobody attending the webinar today needs to be told that the electric utility industry is contending with historic levels of change. In fact, the volume and diversity of change utilities must manage can defy easy descriptions. So let's use a few examples. One is simply the fact that after years of flat load growth, demand for electricity is growing fast. Earlier this year, the consulting company ICF released a report forecasting that electricity consumption could grow by 9% by 2028 and 18% by 2033. There's several drivers of load growth, though the one that attracts the most attention is electricity demand from the data centers needed to power cloud computing and artificial intelligence applications. There are many implications of load growth. For utilities, load growth requires significant investment in physical grid infrastructure, including transmission lines, substations, and other grid equipment. In fact, a recent report by Deloitte found that power sector capital investment reached an all-time high of $179 billion in 2024. Deloitte also forecast high levels of sustained investment, including $1.4 trillion between 2025 and 2030, and similar levels of spending through 2050. Optimizing the benefits of all the new grid equipment being added is not inevitable. Modeling and managing equipment across utility functions is a key challenge to ensure accuracy and efficiency in how data is exchanged and used within a utility and shared with neighboring utilities or market operators. Another big trend is the continuing influx of distributed energy resources, or DERs, to the grid. The consulting company Wood Mackenzie projects that America will add about 217 gigawatts of DER between 2023 and 2028. At scale, DERs can change grid dynamics, introducing bidirectional power flows, enhancing flexibility in congested areas of the grid, and affecting stability due to lack of inertia. Again, utilities need a single source of truth for modeling, collecting data, and sharing data with internal and external stakeholders. Unfortunately, most utilities lack that single source of truth at the very time they need it most. On today's webinar, we're going to hear about the many benefits utilities, their customers, and the grid receive when network model management becomes that single source of truth. So, what exactly is a network model management system? Very simply, it's a centralized system that provides a standards-based single source of truth for grid network data, making it easily accessible to subscribing systems. We're fortunate today to be joined by speakers who have firsthand experience about why network model management is an essential tool in successfully managing an increasingly complex grid. We're delighted to have two terrific experts from Ameren Corporation, the parent company of utilities serving customers in Missouri and Illinois. We're also joined by speakers from the consulting company Xtensible and AspenTech, a software company that is working closely with Ameren to deploy the Cimphony Network Model Manager. AspenTech, is now part of Emerson and offers industry-leading control and automation software for the power and utility industry as part of its digital grid management product suite. Starting as Open Systems International, or OSI, more than 33 years ago, AspenTech's DGM suite serves the power generation, transmission, distribution, microgrid, virtual power plant, electric transportation, and gas pipeline management segments. In November of 2024, Open Grid Systems, a global provider of network model management technology and a pioneer in developing model-driven applications, was acquired by AspenTech, joining the digital grid management product suite. Open Grid Systems' unique model-driven technology enables utilities to view, edit, transform, and analyze power system data with extensive support for industry-specific interoperability standards, enabling efficient data sharing across utility stakeholders and system operators. Combined with AspenTech's DGM suite, the integration of Open Grid Systems technology creates an unrivaled data-centric infrastructure to enable alignment across utility functions, resulting in improved reliability and overall grid system performance for transmission and distribution companies. We're going to learn about the role of Network Model Manager in moving towards Ameren's Grid of the Future vision. We're also going to hear about how the project has unfolded so far and lessons learned along the way. So we have a lot of ground to cover, and I'm going to first introduce our speakers just by name and title. They may say something more about themselves once they start speaking, but let me just introduce who you're going to be hearing from today. First up is Mike Daniels. He's Director of Digital Grid of the Future and Analytics at Ameren. Then Tyler Friedel. Tyler is the Technical Product Owner for Ameren's Digital Grid of the Future. We're also joined by Jim Whittle, a Senior Product Management Specialist for the Cimphony suite of products within AspenTech Digital Grid Management. And then we have Arnaud Gradin. Arnaud is Director for the Power Business Unit at AspenTech. And finally, we have Phillip Jones, Vice President of Architecture and Solutions at SAM's Digital Data Services Division, which includes Xtensible Solutions. All right, that's a long windup to get into our great speakers. So I want to jump right in. Excuse me. Now, Mike, you're going to go first. In my introduction, I gave a high-level description of Ameren. Can you flesh that out a bit and tell the audience a bit more about Ameren?
Yeah, sure thing, Chris, and thanks for that introduction. Good morning, everybody. I'm Mike Daniels, and I lead our digital GIS, grid analytics, distributed energy resources, and network model management teams at Ameren. And I've been with Ameren for about 5 years now, but I've also worked for Schneider Electric, Aclara, and National Grid, developing and implementing solutions for utilities. And over the course of my career, I've been able to visit some 30 countries. If you could go to the next slide, please. A little bit about Ameren. Ameren Corporation, based in St. Louis, Missouri, includes both Ameren, Missouri and Ameren, Illinois, as well as our Ameren Transmission Company. We employ about 9,000 personnel, and we power the quality of life for 2.5 million electric customers and more than 900,000 natural gas customers across a 64,000 square mile area. We've got approximately 7,000 sub-transmission or distribution feeders and also 8,000 miles of transmission lines. Next slide, please. Chris highlighted some of the key challenges that we're all facing and just wanted to give Ameren's perspective on this. As previously highlighted, the clean energy transition is profoundly impacting Ameren's electric and gas businesses and the drive toward the integrated energy grid. We see the energy grid really facing increasing renewables, distributed and intermittent energy sources, and certainly, as Chris highlighted, expanding significantly to support growing data center demand and electrification. But as you can imagine, the integrated energy grid requires an extremely strong and resilient technology backbone to orchestrate a dynamic, complex, and decentralized array of interconnected assets. And that's certainly what we want to focus on this morning. Next slide, please. I want to share with you some of the key applications that form the backbone of our ecosystem. These applications are integral to our operations and help us maintain efficiency, accuracy, and innovation across various domains. First, we have Esri's GIS platform and ArcFM from Schneider Electric, which are the cornerstones of our editing and design solutions. Next, we utilize Hitachi's Network Manager for our Advanced Distribution Management System, or ADMS, And ADMS helps automate and speed up outage restoration, improves reliability, and certainly has an impact on reducing customer impacts. For distribution planning, we rely on DNV's Synergy product, and this application provides us with comprehensive analysis and planning capabilities, allowing us to anticipate and address the needs for our distribution networks more effectively. And then when we transition over to sub-transmission planning, we use Siemens PSSE product, and this tool is essential for enabling us to ensure stability and efficiency in our sub-transmission operations. Work and asset management are certainly critical to our success, and for this we turn IBM's Maximo. And this application helps us manage our assets, track work orders, and ensure our maintenance operations run smoothly and efficiently. And lastly, I want to highlight our data lake operations, where we leverage Databricks and AWS. And these platforms provide us with scalable and secure data storage and processing capabilities, empowering us to harness the power of big data, largely from our AMI and customer systems for data-driven decision-making. And you'll see that each of these applications, as Tyler gets into the details, are important aspects of our grid network model management solution. If we could transition to the next slide, please. So stepping back and thinking about the key challenges that we faced when we got into this project, I just want to highlight a few aspects here. First off, lack of a single standards-based, and standards being the key operative there, source of truth for our network models. We certainly, as I imagine many of you, have a number of siloed and very costly integrations to maintain. We've had data challenges which have prevented the adoption of advanced features within our ADMS and planning applications, and also have inhibited some of our analytics capabilities in the past. We've been unable to track feeder switching history and understanding how a feeder was configured at a certain point in time. And then certainly a big aspect of this is looking forward to DR applications that are on the horizon, applications such as DERMS, our ability to support dynamic hosting capacity, and really stepping back and thinking, how do we avoid another costly point-to-point integration to support those applications? And ultimately, the lack of a network model management solution limited our flexibility when replacing or adopting additional grid-based applications that we bring into our portfolio. Next slide, please. And before I hand this over to Tyler to get into some of the details of our implementation, I just want to quickly highlight our project phases and our key partners here. We kicked off with a strategy and vision phase. EPRI was absolutely a key contributor to this, helping us to really give us a good outlook and frame up a business case for this investment. We then quickly turned to Xtensible solutions to help us with our planning, requirements, RFP development, roadmap, and also a key aspect of this was the architecture of the solution. And then lastly, as we segued into the design and implementation phases, Xtensible has remained a key partner for us. And then, as you might imagine, we turned to AspenTech or Open Grid Systems at the time for their network model management solution. So with that, I'll turn it back to you, Chris.
Great, thanks, Mike. Now, as you mentioned, we're going to bring Tyler into the conversation now. And Tyler, if you'll remember from my brief intro, is the technical lead on the network model management project. So Tyler, I'd love to get you to talk a bit about how this initiative supports Ameren's Grid of the Future vision.
Yeah, absolutely, Chris. Thanks for the intro. So as you can kind of see on the slide, I've been with Ameren for about 6 years after graduating with a degree in computer engineering, and immediately upon joining Ameren, I became responsible for our Synergy electric models. And when I wasn't doing that, I was just doing regular distribution planner activities. And then I moved into the role of technical lead, technical product owner on our grid network model management project with Cimphony in 2023. I'm still responsible for Synergy, but Basically, what my new role is to handle all the technical details about how our grid data should be mapped and used, and be a holistic expert on our NMM project, and collaborate with the other folks at Ameren that have more specific expertise to make sure that we're doing the right things and supporting the right use cases. So if you could go to the next slide. So here I just want to jump into the first implementation phase of the project here at Ameren. So for us, one of the biggest drivers of the network model management project was just the desire to more fully utilize the advanced applications within our ADMS system. Obviously, ADMS is a really big investment for, I think, any utility. And it's a priority for us to get the maximum value out of that investment. So to enable us to do that, we undertook this initial implementation stage of our Cimphony product with AspenTech. So we put this into production at the end of 2024, and we're currently, all of this is in production and being used to perform all the updates to our ADMS models here at Ameren. So on screen, you can see the conceptual design diagram for our implementation, with Cimphony represented by the beige rectangle in the middle, and then the initial periphery applications on the sides in the more bluish color. So starting at the top left with GIS, we've got an integration with our GIS system, and we consume the changes to our as-built network from GIS on a daily basis there, and we bring those into Cimphony. With load to the bottom right direction, that integration is with our AMI load repository and Databricks, and we consume 576-hour load profiles for each distribution transformer, and those are based on aggregated AMI data, and we update that data on a monthly basis. I also want to mention that within the beige Cimphony rectangle there at the bottom, you can see the type asset catalog. So what that is an application within Cimphony that we developed in partnership with the Cimphony team, that it's our common type asset catalog that contains rating, protective, and impedance information for all the different types of equipment at Ameren. And then the combination of all those data sets are consumed by Cimphony, and then they're all mapped and written into SIM format models. And then Cimphony acts as that single source of record to provide ADMS with the data that it needs for grid operation. And that integration to ADMS is upon request. So they can request that as frequently as they need, and it takes around a half an hour to do all 7,000 of the feeders within Ameren. And then finally, with our second release at the end of 2024, we also added some integrations that allow Cimphony to consume some data from ADMS, namely the as operated state of the network as a snapshot once every few minutes, and then also the associations between SCADA points and their network location, and that integration is daily. So the completion of this implementation has been of great value to Ameren, and some of those are listed at the bottom of this slide, but just to touch on a few of those, we've increased the frequency and the reliability and quality of our ADMS model updates already due to this deliverable. We've also unlocked the advanced applications within ADMS that we've made reference to a couple of times here. That for us, that's going to start with the load flow and then build towards things like state estimation and FLISR. And before our NMM project, the data that we needed to drive these applications just wasn't available. And really, this was probably one of the biggest, if not the biggest driver behind our purchase of Cimphony. And it just promises to reduce the need for planners to be consulted when we're talking about switching decisions in the operational environment. And it also, through the use of that future state estimation, will allow us to optimize truck rolls. We've also enabled the tracking and analytics on historic grid conditions by consuming the needed information about the operated state of the grid and the exact location of our SCADA measurements. So for an example, if we have a customer to complain that they're having voltage issues, and it was a few days ago between, say, the hours of 9 and 12 in the morning, basically we'll be able to hop in our little time machine in terms of data and be able to see if something was abnormally switched at that time, or if we're observing that issue within our SCADA data or anything like that. So a lot of value there. And then finally, we no longer need to maintain direct integrations between GIS and ADMS, and that integration was pretty costly. So as this implementation continues on to other phases, which I'll get to in a moment, the overall number of point-to-point integrations at Ameren will decrease, and that'll lead to a reduction of O&M for us. So if we can just move to the next slide, please. In terms of what we have coming up, right now we're working on transitioning our planning solutions into subscribers of our grid model. And first up is distribution planning, which we're in the process of implementation right now. For this phase, our deliverables are enrichment of our load model within the SIM. And what we're going to do there is include loading at a customer level and have that be complete with an assignment to a conformant 576 load profile. And that'll allow us to do time series load flows within Synergy. We're also adding in some source impedance data to our SIM model, and we're adding in feeder, substation and feeder and bay unit ratings and forecasts to our SIM model, because those are also required within Synergy. And obviously, all this being added to the model with the intent of integrating directly with Synergy and using our SIM model and the type asset catalog for distribution planning. So in terms of value from this phase, what we anticipate is, again, increased frequency and reliability and quality of model updates. Right now, we do that weekly, and it's a pretty long-running process, and we anticipate that to be a daily update after this implementation, and also to run quite a bit more quickly. We also, as I mentioned, are enabling time series analysis with the inclusion of those 576 load profiles. And we also are looking to enable the modeling of those as operated grid conditions within Synergy, using the data that we are consuming from ADMS. So then finally, the biggest value I think here is just improving our ability to model and plan for DER on the distribution system. And these are especially valuable in our Illinois business line because Illinois is a deregulated supply market. So there have been a lot of growing pains as we've started to see more and more DER interconnection requests over there. And this will help us to pay increased attention to those DER interconnections, and it's just all the more important with those that we have consistent and accurate modeling practices. And also, we're moving towards posting DER hosting capacity maps. And those DER hosting capacity maps are due to be completely posted in Illinois in 2026. And basically, those will enable our customers to more efficiently optimize their DER siting as they put in interconnection requests. And that's been a big driver of this phase of the project, and requires us to move from that traditional peak system modeling to more of a dynamic time series modeling within Synergy, and NMM is an integral part of that strategy for us. So if we go to the next slide. And then the other project that we have in process right now, and we're a little bit earlier in the implementation here, but similarly to our distribution planning phase, with our subtransmission planning phase, we plan to deliver an integration from our SIM model, including the type asset catalog, to our PSSE models for subtransmission planning. And we're also going to deliver an integration with PT load to store the calculated substation transformer ratings within our system of record from that tool. So the anticipated values here are, again, increased frequency, reliability, and quality of those PSSE model updates, reduced cost of that PSSE model maintenance, and then enabling that modeling of as operated grid conditions within PSSE as well. So it's really noteworthy on this particular phase for the values that today all our PSSE models at Ameren are maintained manually by our planning engineers, and it's really a huge amount of effort for them. It's close to a month per planner, and it's also repetitive effort because all of those updates should also be being made to our GIS system. So eliminating the need for these manual processes is going to lead to a ton of O&M savings and save time for our planners, as well as increasing the consistency in those modeling practices. So I think that's all I have for implementation here. I'll throw it back to you, Chris.
Great, thanks, Tyler. Okay, I just want to remind the audience to please go ahead and if you have questions, things that you've heard already that you want to follow up on, please enter your questions, and we'll try to get to as many as we can later on after our speakers have completed their presentations. So now we're going to shift over. We just heard from Ameren and some of the specific experience they've had in their network model management journey, and we're going to take advantage of Phillip Jones. He has wide experience in the industry and is going to be able to give us a broader perspective. So Phillip, what I'd like you to do is, if you don't mind, tackle 3 questions. The first is tell the audience a little bit more about Xtensible and what Xtensible does. Talk about your role in this project, and then give us a bigger picture view of how other utilities are using network model management.
Thanks, Chris. Yeah, so Phillip Jones. I've been working the electric T&D space for over 37 years now. Starting off as doing real engineering work, planning, design, construction supervision, that type of stuff, and then had a keen interest in the digital side. So pretty early on, started working a lot around GIS systems, and then this whole notion of the asset life cycle from planning through to eventually operate and maintain. So Xtensible has been around for a number of years. This was our 25th anniversary. We were acquired by SAM last year, and now part of a much bigger organization, about 1,500 people. I want to start off by giving a shout out to the EPRI folks that have been driving and trying to promote this whole notion of network model management, both on the transmission and then evolving into the distribution side. And Ameren, with Mike's leadership, were pretty early to sign on with that initiative. And we came on board at I think a crucial time. We were invited to come on board this project, yeah, it's been a pretty exciting and very fulfilling project. Can we go to the next slide? So I want to start off big picture. So one of the things is that when people think about network model management, we've got to be careful we don't pigeonhole ourselves too much. Important to note is that it is part of the larger asset life cycle. And people would have heard the term digital twin being thrown around as well. This is essentially the cornerstone for a digital twin strategy. Once it's fully fully implemented. So I think that's the one key point to understand. Tyler mentioned a bunch of advantages, problems that were getting solved, but there's so much more that can be leveraged off a network model management implementation. Next slide, please. So one of the things that you find, we found it at Ameren as well, every single utility that we have worked with sits with the same problem. Engineers are very focused on being results and problem solving orientated, so they will do the best they can to accomplish what they need to do with the tools they have. But the downside is that you end up with a lot of shadow IT, Excel spreadsheets, access databases, and so forth. There's a lot of duplication of effort in managing the data. There's very little reuse. We've seen some attempts to do that, but it's usually not well architected. So we end up with many silos of excellence. A lot of inconsistent data. So the typical paradigm of many clocks on the wall, and which one's correct. And then also, people may trust their own data, but how do they know it's current? How do they know if something hasn't changed somewhere else? As an example. So classic situation when one starts in a journey like this, and the purpose of the NMMM solution is to resolve all these issues. And you saw from Tyler's slides there's some hints about how that gets accomplished. Next slide, please, Chris. So fundamentally, it's important to note that the same data is used across all the different business functions and the asset lifecycle value chain. It may have different states, different statuses as it goes through, but essentially it's the same underlying data. And one of the beauties about using a standard model like the CIM, the Common Information Model, which is the foundation for a lot of the IEC TC57 standards that deal with data in the electric utility space, is that this all hangs together pretty well. A lot of very smart, very experienced people have been developing the CIM model for many years, and it's a pretty robust model, particularly in this asset lifecycle space. Next slide, please. So not all network model management applications are built the same. So there are a couple of very key functionalities or features that one needs to evaluate when you do evaluate a network model management system, that need to be aware of and evaluate a potential solution against that. I'm not going to go through each one of these, but a couple of key ones I do want to bring out. And one of them is this whole notion of network model version management, branching and merging, and also the ability to then, as Tyler alluded to, is be able to go back in history or even look at models in a potential future state if you start including planned and designed extensions to the network. We spoke about open standards. We highly recommend that a product leverage the CIM model and the standards around that, the IEC standards. And a couple of other things that are important is this: what the CIM supports is this logical separation of equipment and asset data, which is extremely important for the whole asset life cycle to make it work well. We can go to the next slide. So in conclusion, and I mentioned this earlier, so NMM has the ability to be the cornerstone of your digital twin strategy. If you think about all the sources, the MMS has been a point where you get the assimilation, the integration of the data, managing different timelines, because the planners and the designers and the operations folks obviously have different timelines they deal with. So MMS being that sort of shock absorber for that, and then presenting that data for analytics and AI purposes as well. So there's a lot of analysis, both operationally, asset management, customer. The range is so wide, and having a solid network model to underpin all that is extremely important. And that concludes my set, Chris. Thanks, back to you.
Great. All right. Thanks, Phillip. Now we are going to turn to Jim Whittle now, and I think Phillip's comments kind of set us up nicely to talk a little bit more specifically about the Cimphony Network Model Management and the solution. And so, Jim, I'm hoping you can walk us through that now.
Absolutely. Thanks, Chris. So yeah, as I mentioned, I'm Jim Whittle. I'm a product manager with AspenTech. Previously, having worked with Open Grid Systems, so at the start of the Ameren project, I've been here since about coming out, so 2023. Prior to that, doing sort of research work at Strathclyde University. So if you're wondering why I'm the only one on the panel who seems to be wearing a jumper, it's because I'm talking to you from Glasgow, where we had our 2 days of summer last weekend. So it's back to wet and rain. But if we can move on to the next slide, please, PJ, and I'll happily talk a little bit about network model management and what Cimphony's been able to do to help Ameren in this project. So I'm sure most folks in the audience are probably familiar with the concept of network models for distribution systems, but for those who are maybe not from that background, essentially, as Phillip said, it's a digital representation. It's a representation of the physical network. It shows the lines, the switches, the substations, transformers, etc., and how the electricity flows through those assets across the network, and then ultimately down to the homes and businesses it supplies. So these network models are very useful in terms of capturing how that energy is likely to flow, but also in terms of thinking about grid upgrades, outage management, and as was mentioned, DER integration. Broadly speaking, what Cimphony is aiming to provide is, in this project and in others, a single repository for network model data, not necessarily owned by a specific analysis software or a specific operational system. So for this project with Ameren, our goal was to create that central neutral facility for storing, tracking, managing the network model, and about creating that single repository for the large volumes of data produced across distribution networks these days. You can see on that diagram, we've got potentially different sources of data, be that data coming from planning, from GIS, from assets, and also then systems that might subscribe to that network model that require the data. And network model data encompasses a lot, more and more now these days as networks move towards bringing in more low carbon technologies that require more control, as they move towards greater degrees of monitoring, control, automation. All of this requires more data. This can include electrical parameters, topological data, geospatial information, DER data, operational statuses. It goes on. Essentially, this system has to be aware of everything on the network in terms of its position, its status, connectivity, etc. So that's where things like the IEC SIM come in and allow us to use that standardized format to bring together these data from different sources and amalgamate them and track them. So, prior to starting this project, Ameren had been, they were trying to pass their full GIS model along with various parts of inferred connectivity data across their ADMS. And this data is what allows the ADMS to manage the network based on things like asset location and connectivity and other information. Cimphony allowed us to make various time-saving steps in comparison to what had been a previously quite manual process that involved various workarounds and maintenance risks in terms of, who owned the product and who knew how it worked. So Cimphony provides a means to manage things like the transformation from the various formats. So in this case, our GIS, for example, we can pull that data in, we can transform it into SIM standard data. We can run validations and verifications in the data to check things aren't missing, that data is correct, it's how we expect to see it. We can run all these validations. We can store the data, persist IDs through so that we can look through object registries to make sure we know where things are, and track all of those changes made to the model over time at an individual object level. So if a GIS feeder updates, for example, we can take that updated feeder, pass it into Cimphony, and then track the objects within an individual grid model part that have been updated. And we're able to then do all of this before transforming the data into a format used by the ADMS for export. So in this case, with Ameren, we received all the information such as like measurements and temporary states back from the ADMS as well. So there's this constant back and forth and transforms and validation verification that Cimphony is able to carry out. So Cimphony gives utilities like Ameren the means of doing all of this in an automated fashion with full traceability in that industry standard data format, with the ability to run quality assurance and make sure the data can be reliably accepted by the ADMS. So what Cimphony is able to do then is function as a system of record and track the model as it changes and pulls those various sources of data into that single repository and creates a complete picture of the network at a given point of time, managing the toing and froing in a more automated manner. So in this and other projects, we're also able to leverage Cimphony to not only bring data in from different sources, but also to manage it. So to create things like assemblies of multiple feeders. So say if Ameren wanted to analyze all the feeders coming off of a particular substation, we can build out schematic and geographic representations of the network. And we can also use things like branching and projects and IEC difference models to start to build out different scenarios, maybe to assess potential future states of the network. So in any project with Cimphony, it's as much about providing that flexibility in the use cases as it is about a means of providing, a means of obtaining that repository of reliable data for all those consuming systems in one place in a standardized format. So that's kind of what I've got. So I'll hand over to you, Chris, and
Great. Yeah. Well, so we're gonna. I just want to remind the audience to please go ahead and ask any questions that you'd love to have addressed. We're going to get to audience questions here in a moment, but before we do, we're going to bring Arno into the conversation. And so, Arno, we've covered a lot already. There's been a lot of topics. Some specifics and more broad industry insights as well. I'm kind of hoping you can bring us home here and wrap this all up. And to do that, could you summarize the holistic value network model management and specifically Cimphony delivers to utilities?
Yeah, absolutely, Chris. I think there's a lot of great content, right, for the audience, and I guess a lot to digest today, right? So just to start, right? So I'm Arnold Gredin. I work for AspenTech. Been working for AspenTech for about 4 years. I work in the product management area, and very much my role is looking at all the modeling part, pretty much IT/OT, right? Because we also have a big part with AspenTech that runs, like our SCADA, EMS, ADMS solutions that we offer, where we also, need to provide maintenance solutions. So my whole job encompasses this whole modeling aspect, right, that we have within AspenTech now. If we just move to the next slide, PJ, I guess to try to moving one more, if I try to summarize, right, with all the content that we've heard today, I think there was a lot of good content, right, provided by Phil, Tyler, Mike, and Jim here. To me, the way I see it, right, as the true challenge, right, is really in maintaining data consistency and semantic, right, the structured interoperability across systems and processes, and this has to be done over time, right? So we heard it. It is a challenge that grows exponentially, right? As utilities modernize their grids, they integrate DERs, they adopt, advanced operation technologies. So NMM really addresses this by establishing, as it was said, right, a centralized, standard-based foundation aligned, on the industry-adopted SIM, the Common Information Model, for grid data that not only ensures, alignment across planning, market, operation, as well as, regulatory functions, but also enables, scalable, automated, and future-ready decision-making. So, as I just said, right, the grid is becoming more dynamic, driven by market signals, sorry, real-time operations, the DERs. So the standard as built and as operated view, right, they're no longer enough, in my opinion. Utilities are increasingly challenged by fragmented and consistent network models across the departments. So it makes it very difficult to track changes, reproduce results, or even respond quickly, to regulatory and planning demands. So the way I see, Cimphony and what it brings is or what it addresses is really this, or addresses those challenges really by providing what I kind of like to call really this as orchestrated, right, view of the model. So it's live, it's a contextual model that reflects how the grid is being actively managed and coordinated across all those systems. And beyond this whole structural alignment, right, Cimphony extends the visibility into grid resources and enhances both, obviously, the planning and operational observability. So this gives, pretty much utilities a clear picture of the current network, but the ability also, obviously, to anticipate what's coming as actionable insights. So if we go to the next slide and just pretty much to kind of conclude or wrap up here, what are the Cimphony particularities, right? Cimphony is fundamentally, right, the field-proven grid data and network model management, right? It's this centralized, structured, and standard-based data-centric infrastructure that is built on a persistent data storage layer for model-driven data, which obviously includes SIM. It supports real-time meta model extensions, so you can dynamically enrich the network model with new attributes or structures, right, without disrupting existing systems or workflows. It was kind of mentioned earlier, but it's project-based, but also time-based solution, right, that uses or is built on modern technology to make it fast. Models are becoming bigger, so it needs to be scalable, it's secure, and which we can deploy actually either on premises or on the cloud or as a hybrid type of approach. And obviously the document is fully documented. So just as a note on the version control, the time-based approach, right? Cimphony really allows, teams to track how the network model changes, compare different scenarios and understand how the grid is evolving across different planning horizon. And it helps, ensure that planning and operations stay aligned. Past conditions can be reviewed and future decisions are based on a clear, consistent view of the system. So just as a way for me to wrap it up, kind of encompass a little bit of what was said, right? So in today's data-driven, utility environment, which is very much what Mike was saying, right? Accurate and well-integrated grid data isn't a nice to have, right? It's becoming essential. So as utilities such as Ameren work to improve reliability, control cost, and meet, growing regulatory demands, we kind of anticipate, right, that, most transmission and distribution operators will eventually need an NMM. So NMM will play and plays already today this integral piece that provides it and enhances, pretty much for the whole AspenTech digital grid management software portfolio. And it provides what? Open data to really improve that accuracy and be the true source of data for both transmission and distribution models. It provides open standards really for simplifying, yet having consistent data sharing and regulatory requirements. So we follow SIM. We also have, full and open APIs that can be leveraged, for third-party systems. And we provide open access to enable automation of services and access to data to enhance, very much observability across businesses and operational domains. So that's, for me, all of what, can be summarized around NMM and what Cimphony brings to the picture here. So back to you, Chris.
Great. All right. Well, we are going to jump into audience questions, and I want to thank everybody for being engaged and submitting your questions. We'll get to as many as we can here. So the first question, this is a question for Tyler, and I'll just read it. You mentioned that it's possible to use past data to get an idea of the configuration of the grid in the past. How is this presented to the user? Is it a full view of the model map where the user can zoom in and out and pan and click on a device and see the load at that time on the selected device? So practical question. Tyler, can you take that one?
Yeah. So right now, that's essentially what it looks like. You can load in. We typically just load in subsets of the network, but you can load in the network and then basically be able to pan around and see where we have any non-normal states on switchable devices. And then right now we're able to see where SCADA is, at least. We have not included the actual measures themselves as of yet, but this is a relatively new offering within Cimphony. So we're collaborating with Cimphony and with our folks here at Ameren to sort of drive that offering and that UI in the direction that it's most useful for us.
Okay. Anybody else want to add to that, or should I jump to the next question? Okay, I'll jump to the next question. All right, so this question is for Mike. And the question is this: how far have you gone to configure your DERMS to handle the FERC 2222 mandate?
Yeah, I can take that one, Chris. This is Mike. To be clear, we're early stages of DERMS. In fact, we're going to be issuing an RFP here pretty soon. But as we've thought about DERMS and ultimately the impact of FERC 2222, and just for those that aren't necessarily familiar with FERC 2222, this is where they're allowing aggregated DERs to participate in the wholesale market. Fundamentally, what we see is the need for really good grid network data to support DERMS applications. And so that's certainly been a key driver for us as we anticipate that. But specific to FERC 2222, in that network model, we see opportunities not only to help aggregators in terms of validating the states of DRs, but also taking in consideration outage situations that we might want to communicate with the aggregators as well, just to name a few use cases. So just to recap, this is an important aspect of what we see with our DERMS provider once we go in that direction, and we see this network model solution and providing a SIM-based data sets for that being key.
Great. Okay. Here's another question, and just let me know who wants to take this one, and there can be multiple answers if you'd like. The question is this: for the NMM projects, do you see opportunity to leverage AI to improve the outcomes? Anybody want to tackle that?
I mean, I can jump in and probably then let someone else with better qualifications jump in after me and tell me that I'm completely wrong. But seeing as I get AI put in my bio, I should probably say something. Realistically, when we're talking about machine learning, it's all a question of data. So, you know, if we've got a system where there's a lot of data coming through and we're able to build up and train models, then absolutely. And I think there's definitely a use case in there for saying, like, we've got all this data in one place, and you know, we can perhaps train models to run things like, you know, instead of having to run full load flows to try and figure out where the most constraining factor on a feeder is likely to be. I know when we get into the whole AI discussion, and is it, you know, sort of big online models, there is a security question there as well as to where the data is going. So it's an interesting one in terms of just trying to sort of balance security for data, because a lot of this is, you know, especially when it gets to transmission, that there's a, you know, degree of national security involved there. But you know, I'd certainly love to see more kind of machine learning projects using this data. Of course, there's a hell of a lot of data in a sim model, so it'll be about, you know, picking the right data as well. So, but I'm happy to have other people dive in there and you know, argue with me.
Anybody else want to add to that?
Yeah, I'll add to that. So I think there's two parts to this. The one is on the consumption side, using the network model, which is essentially a massive graph, to do some AI, you know, on top of that. The other part is actually using AI to improve the data quality and the validation of the network model itself. So, you know, I think on both sides of that pipeline, AI could play a large role. We at SAM, we are working towards building out, particularly on the front side, in terms of doing data quality validation, network validation, through you know, through image, object recognition, and so forth, to improve the quality of the network model without having to send people to the field, as an example.
Okay, great. Well, we're running up on the top of the hour, so I'm just going to try to fit in a couple more questions. So hope you stay on. Looks like people are hanging with us, so appreciate that. All right, here's a question. It's a bit of a longer question, and maybe Philip, if you want to take this one. I've been researching the SIM specifically for NMM in the transmission planning space. It's been extremely difficult to find clear information, but from what I understand, the SIM is more mature in the distribution space. And here, that gets to the question. Have there been any changes recently in SIM versions, resources, tooling that have made the SIM more usable in the transmission planning space and interoperable with those tools, TARA, PSSE, raw files, etc.? Is this a sign that the industry might be moving in that direction, or is it a skill issue, or does it just require grit? Philip, you want to take that one?
Sure, I'll take a shot at it. So I think just to start off with, the distribution parts of the SIM were only added much later. It started off as highly focused on transmission on balanced networks. So up to SIM 14, that was the case, and in SIM 15 onwards, the distribution parts were added. There was also a big change in the way transformers were modeled, specifically to accommodate for the distribution unbalanced network. But having said that, I think that the main part of this question regards to the actual model transformation between, say, a SIM and a PSSE file and so forth. One of the key features of a network model management solution should be the ability to transform from a call it a vendor agnostic SIM model to a proprietary model that are used in some of these planning tools, and both directions. So produce let's say a version of the as-built as part of your base case, and then also basically data flowing the other way, be able to ingest these planning cases and store them, and then as it goes to a approved plan, approved design, and it gets constructed, the ability to merge that back into your as-built version, as an example. So I don't know if that fully answers the question, but we can certainly take that offline if needed.
Right. Okay, so I'm going to wrap up with one final question, and whoever wants to jump in and tackle it can do so. The question is this: from an integration perspective, did you leverage a single platform or use web services APIs from each product vendor that provided components of the solution? Anybody want to weigh in on that question?
Phillip, do you want to maybe talk a little bit about our strategy when it came to integration, and then maybe if there's a little more specific, I can add some detail too. But
well, so maybe just to start off with, we had a decision to make whether we do the transformations in the integration layer, or we do that, or we do that as part of the NMMS interface layer. Cimphony had a lot of these capabilities that had already been done, so the choice was made to actually do that as part of the Cimphony layer. So the Ameren integration layer was really just essentially a transport layer with a lot of validating, basically workflow validation and capturing all those so that there's visibility in terms of the data flows from a operation and maintenance of the solution. The Ameren had MuleSoft as the enterprise integration platform, so that was utilized as part of the first phase. On the second phase, there are some other cloud-based technologies that are being looked at, are being implemented at this point in time.
Yeah, and most of, if not all of our integrations are sort of loosely coupled, typically RESTful API based. Trying to make everything that we do here as event based as we can. Some things are somewhat time based in nature as well, but as much as we can, trying to stick to that event driven type of architecture when it comes to integration.
And I think I know we're running out of time. The other key part there is that it was architected and designed such a way it's easy enough to turn it into a full event driven. Right now there's essentially a scheduled timer for the daily updates, but any one of those can be triggered event driven.
Right.
All right. Well, we have taken even more time than we originally intended, but I think that's a function of people being really engaged. So I really want to thank the audience for your great questions and for sticking on and being engaged with the content. Really appreciate it. And I obviously want to thank our great speakers, Mike, Tyler, Phil, Jim, and Arnaud. They really added lots of great insight and really made it a terrific presentation. So with that, I want to hand it back to PJ to wrap us up.
Thanks, Chris, and thanks, panel. Fantastic conversation. For our audience, look for an email from us containing the link to the replay, and also take a moment to complete our survey. so that we can get your feedback. We'd love to continue to provide events just like this with excellent content. From everyone here at Energy Central, thank you for joining. We look forward to seeing you on a future power session, and this does conclude today's presentation.